So in summary, we have seen a little bit about lists. They are mutable sequences, but they're much more powerful than what we have seen in this lecture. In our next lecture, we will explore their power in greater detail. We will see that lists don't have to have items of the same type. The lists that we saw in this lecture all had string objects inside. They were homogeneous. But in general, lists can be heterogeneous. The 0th item could be a string, but the 1th item could be, let us say, an int, and the 2th item could be a float. The 3rd item could be another list. Lists are in general heterogeneous, but we will explore this idea in our next lecture. Now, it turns out that many of the operations that work for strings, such as slicing and the in operator, also work for lists. But in addition, there are many other methods and functions that work very well for lists. So for example, we can sort the items in a list. Now this only works when all the items in the list are comparable. I just said a list could contain items of different types, for example, an integer and a string, and it doesn't make sense to compare those two things. But if the items are all comparable, for example, they're all integers, then you can sort them. If the items are all strings, you can sort those in dictionary order, or what we call lexicographic order. So sort is a very powerful method available in lists. Similarly, we can add new items into a list using an append method. This will add the new item to the end of the list, appending it to the list. Similarly, we can extend a list with many items. We can remove that last item using the pop method. We can do counting, and we can apply the max and the min function, and there are many other functions and methods that are available in lists. Gradually we will see some of these, but in this course we will not get to see all of these. So if you're interested, go read up about lists. While you're reading up about lists, also take a look at tuples. Finally, in this lecture, we saw exceptions. Exceptions allow us to write code that is potentially more readable. We want to do some operations, but we know that in some cases that could lead to exceptions. So we put those potentially dangerous steps inside what we call a try block. Once again, the syntax is the keyword try, colon, and then indented all the operations that could potentially cause an exception. And then we have an except statement. And it turns out we can have multiple except statements. So once again, go read the documentation if you would like to know more. We have just seen a very basic introduction to exceptions in this lecture. So we can write a tuple of the specific exceptions, or we can leave this out to catch all exceptions. That seems like a very useful thing to do, but it's not always the correct thing to do. In the case where we catch an exception, we can handle it by doing whatever our client wants us to do in those specific cases. In our next lecture, we will explore lists further, and we will also see another very, very powerful idea in computing, something called iteration. See you in that next lecture.